So I thought this was pretty interesting. And if you go back and you watch the video about testing the fuel pressure regulators on the diesels and how the diagnostics that were given are not all that great, and what a little bit of resistance on the circuit can do to the operation of that regulator and how that's going to affect fuel pressure. Okay, so same truck from the video, 25 GMC Sierra that we're dealing with here. We actually added 10 ohms of resistance to the low side control of fuel pressure regulator number 1. So this is my recording from the scan tool, and you can see desired fuel rail pressure 8,436, fuel rail pressure 8,343. We're pretty spot on, and this is with a normally functioning fuel pressure regulator 1 and 2. Resistance has not been added to the circuit yet. We actually have this set up on a switch. It's a training vehicle, right? This is using our diesel engine performance class. So we can add a little bit of resistance to the circuit just to see what the outcome is. Now, I did this several times. I ran this truck for a few minutes, and I did this several times. It never set a code, which further proves my point. The diagnostic for this would probably lead me to replace the fuel pressure regulator, not diagnose it down to the root cause of the concern, which is high resistance in the circuit, and not very high resistance. The end-to-end resistance on the circuit right now is about 0.5 ohm, half an ohm, and we added 10 ohms to it, so 10.5 ohms. Well, pay attention to the screen there, you'll see what the outcome is. When we added that 10.5 ohms, I'm going to move my slider over down here at the bottom of the screen, right there. My actual fuel rail pressure went to 18,392 psi, and we're only commanding, at 8458. You can see it right there on the screen. So this is going to cause some problems. It's going to cause some issues with the way the truck runs. Now, this is a 25 model truck, so these Global B vehicles, or VIP vehicles, Vehicle Intelligence Platform vehicles, so GM calls it, they're pretty smart. The ECM has a lot of fault tolerance built into it, and eventually it's either going to try to take back control over this, which I'm not 100% sure how it does it, because that's going to be some proprietary information in the ECM that we're not given, about how the ECM works internally that we're not told. But after I did this about 4 times, the engine control module finally said, hey, I'm done with you. I'm going to take control over this, and we're going to get that fuel pressure back down to where it's supposed to be. Which I was really surprised to see that. If you go back to like the 19, 20, 21 model trucks, they didn't do that. Of course, they were not VIP or Global B architecture either. They were still an OBD2 style truck. So these newer control modules we have on these vehicles have a lot of very interesting technology built into them now, which is a benefit, I think, in certain ways, because we have a lot more fault tolerance. The truck may not shut down on us. If this were to continue on, we're what, almost 10,000 psi higher on our fuel pressure than what is desired. If this continued on, this truck would go into a reduced power mode, check engine light would come on, and it would have to be taken in somewhere, and this fault would have to be diagnosed. However, if I'm diagnosing it by the book, I'd probably throw a regulator on it, and when that didn't fix it, then I'm really going to have to dig in and figure out why. And we've had 2 videos out today. The first one, we were doing this with the scan tool, testing the regulator and seeing how it worked, or testing the control of the regulator. And the second one, we did a loaded circuit voltage test using a light bulb, and we used our DVOM. We measured continuity of the circuit. That's where I'm going to find my problem. I'm going to find that I have a little bit over 10 ohms resistance on that circuit when my spec is less than 2 ohms resistance on that circuit from end to end. So 10 ohms of resistance, that doesn't sound like very much, but that was all it took for this to happen, for me to have my fuel pressure go up almost 10,000 psi more than what the engine control module was asking for. So we're going to, let's graph this out and see what it looks like when you graph it. So we can come over here and click on line graph. And you can see right here, so blue is desired, all right? Red is actual. And every time that fuel pressure spiked because of that 10 ohms of added resistance in that circuit, you can see it right there. So it doesn't take much. It doesn't take much. 10 ohms of resistance, that could be, a little bit of water got into a connector and corroded a terminal. That's all it could take. So you really have to dig in deep in certain cases and really dive in and do some diagnosis. And remember, you got to be 50% smarter than the book. The book's not going to tell you everything that you need to know. Hope this helps out.